Well, good morning, ladies and gentlemen. Welcome, everybody, to this National Biodiversity Network conference that we hold each year. This is the 12th such conference, and the title of this year's meeting is, I think, a very apt one. It's Biological Recording Fit for Purpose, with a question mark prominently at the end of that. We have a diverse program. I think it's a very interesting one that will keep you entertained throughout the day. A highlight, of course, is the Sir John Burnett Memorial Lecture given by Sir John Lawton that will be after lunch. This morning's session is going to be chaired by the CEO of the NBN, Dr. Jim Mumford, who's sitting there and ready to take over the proceedings right now. Thank you.
Right, before we launch into the speakers, I'm just going to take a quote from Simon and Garfunkel's seminal Concert in Central Park. We appear to have filled the place. There you go. I need to warn you that the proceedings this year are being videoed. Primarily the video will be of the speakers, but the backs of your heads may feature. And you'll be able to see those videos on YouTube. So if you've never appeared on YouTube before, you could well be there. Right, without further ado, can I call on Keith Porter to give us our first talk on biological recording, change and transition.
Okay, good morning, everyone. Can you hear me okay? You at the back? Okay, thank you. Well, it's a great privilege to be given the opportunity to set the context for today. What I'll be showing you is actually predominantly from an English perspective, but the conference is very timely in this particular area. I've been personally a recorder for over 40 years, probably a little bit more than that. So I now have a job which I think is the best job in the world. I'm employed by a government agency, Natural England, but I'm asked to advise on and help to support biological recording. So it's one of my dream jobs. And I know from my experience that actually having access to good information on species and habitats is the thing that makes the critical difference between doing something really good for biodiversity and failing completely. So that's really what we're about here today. That information that's mobilized by all individuals, recorders, giving of their own free time and supported through public money, your money. That's what we want to make work well. Okay, so let's just start with the point of we're at the crossroads now in this particular topic. There's lots and lots of active debate right now about this particular topic. Most of you will be aware that we're in a period of rapid change. Most of you have got the consequences to try and deal with day by day. We're driven by public expectation. We're driven by new policies, both from government about expectation and international requirements. Technology is beginning to move on absolutely at a huge pace. You know, it's not that long ago since we first had computers, at least in terms of my career. We've now turned the corner, and you'll hear a lot more about that today. And most importantly, we're actually in the middle of an economic downturn, which makes it even more difficult, apparently, but I'll come to that later. One of the things that was pivotal in this area is in the summer of 2011, the government published two pieces of policy, at least in England, the Natural Environment White Paper and Biodiversity 2020. And for those of you who have bothered to look at that or have heard of it, it's some of the strongest support I've ever seen in my career from government for volunteer recording. It actually recognises the value of volunteers and recording, and it's actually putting some of the money behind that to try and increase the support. So the main point really that we're taking from that is that government and others recognise that volunteer data isn't free. It isn't something that just appears out of the ether. There is quite a high cost, and if you want to think about this cost, talk to some of my colleagues in BTO who have managed very, very effective groups of volunteers for many, many years, but they have to actually invest in that. Most importantly, I think the government is trying to engender a different type of partnership. It isn't big government and little recorder. We're all part of the same thing. We're both contributors and we're users of information. It isn't them and us, it's that partnership. More than ever before, there's clarity about exactly what we really need around species and habitat data. And more importantly, there's this full recognition of that recorders get benefit from being able to see their records in a wider context and more rapidly through some of the modern systems. And really the last part there, the parts of the jigsaw, the point here is that from our perspective, I think most of the pieces of that jigsaw are in place. They're there. They're just not working together. You know, we're not quite sure what the picture is. So really, one of the central focuses of what I'm talking about is we do need to all work better together to bring this together and make it work collectively. Just a bit of brief context. I won't spend long on this, but just to remind us that focus in biological recording is continually changing. You know, if we go back to the 1700s when the first records and the first naturalists were around, and now highly reputable international figures, if we can name names, this was a world-beating legacy that we have in the UK that we've never really been able to optimise, I don't think. By the time we get into the 60s, we begin to see the first atlases. In fact, I think this year was the 50th anniversary of the first plant atlas. And BSBI had a conference earlier this autumn celebrating that fact. You could only do an atlas, really, once you had the technology to map it and do it in an efficient way. And it's the technology there that brought in, and mapping became a key thing. Atlases became the thing of the day. People could see their records, they could see the gaps and endeavour to fill the gaps. It was, you know, quite a stamp collecting thing in many ways. And they could see the context for their own data. So that, you know, 1960s was quite important. By the 1970s, once we began to mobilise all this information, people began to feel that actually it was development, built development, that was really threatening biodiversity. So again, there was an enormous effort to build some ability to engage with planners and provide them with information so that they could actually protect some of the rapidly dwindling number of places. So that was the real thing, the planning threat. That began to see the genesis of local record centres in particular, and that was their main focal point to start with. By the time we get to the 1980s, 1990s, we're beginning to have processes to deal with development planning. We're beginning to see a lessening of impact and destruction. Legislation and things like this were helping. But coming to the fore now were the recognition that our countryside was actually becoming heavily intensively managed for other things, farming. 76% of England is occupied by farmland. I think in terms of the last time I looked, the contribution to GDP was something hovering under 1%. Therefore, once we get that in perspective, we have to think how we deal with that. So the 1980s, 1990s, we're beginning to look at agriculture. We see the invention of biodiversity and the biodiversity action plans as a community and political response to these issues. By the 2000s, we're beginning to see funny new words, ecosystem services and an expectation of citizen science, etc. These are all things which we're looking and talking about today. So the point I want you to take away from that slide is that status quo isn't what we're looking for. Change has always occurred and always will. We have to embrace it and work with it. So let's just look at where I think we are now. Biological recording is what we're talking about today, at least what I'm talking about. And there are many definitions, but for now, I think the simple way to look at it is just about capturing information on the what, where, when, the usual basic questions. And increasingly now, say compared with 5 years and certainly 10 years ago, it's actually easier to do that because we've got things like GPSs and mobile cameras and better identification keys. These things weren't around. I used to sit for hours in the evening when I'd been collecting in Europe trying to work out the latitude, longitude of somewhere in Cyprus. It's not a problem these days. It's a touch of a button. So biological recording in the process and essence is getting easier in that sense. Now, why do we do it? And there's lots of people who can tell you better than I can, but I'd summarize it generally, and as a recorder myself, you do it because you're interested, because you're curious, because you like sharing ideas and what you're finding with like-minded people. There's a bit of social issue in there. You do it because you enjoy it, and you do it because it inspires you. And that's something we mustn't ever lose. That's the motivating, driving foundation, the golden goose that drives the whole of biological recording. Now, the sort of things that you like in that are probably like me, and I apologize if I'm not representing your thoughts on this, but seeing new spaces, seeing new places, looking at places you've never been before with the anticipation of finding something exciting, simple things to record, easy ways to submit records, feedback and support, and seeing your data put to good use. You give up lots of free time, your Sunday afternoons, your Saturday mornings, actually collecting this information, your holidays. You don't want that information to go to waste, if you like. The things you might not like as much in that is being taken for granted. Data's free, you know, we just take your data and do what we want. That's a thing of the past. Compulsion. You must go there and you must look there. You must make really complicated measurements. These are the things you don't instinctively like. I'm not saying we shouldn't be doing them. I'm just saying it's something that people do are concerned about when we ask them. Boring places. Let's go and look at this field of wheat and see what we can find. Well, you find wheat. And more importantly, the famous black hole syndrome. I've spent all my holidays and 50 years amassing all this data. I've put it into this recording scheme, and that's the last I ever heard of it. We mustn't ever go back to those days. The sort of challenges that we're now seeing, I've described some of them at the start there, but overall, the main challenge, I think, is not just to maintain the size and the competence of the recording community. I want to see a lot more recorders, more competent recorders, begin to support people to develop. In the professional world, we call it continual professional development. You're allowed to move on. You're allowed continually learning. And this is what really I think the ambition is and the challenge. The other part of that challenge is we must make something happen fairly quickly. Otherwise, all this impetus, all this policy, all this government support and expectation can disappear if we don't begin to see some delivery. So there's a bit of a kick in this one as well. Now let's look at some of the things that we do good and some of the things that we could probably do a little bit better. The sort of successes which you'll all recognise are things like the NBN gateway. There's 80 million plus. I haven't checked it last night, but it's probably more than that now. That's a wonderful way of bringing stuff together, making it accessible. That was the idea of the NBN and the gateway. It's working, and the process is excellent. Whether we support it in the right way is a different issue. There is a very strong local record centre network. I was once told, I don't think he's here, but one of my chief executives once, in about, I don't know, 1995, to pull back from trying to get full coverage of record centres in England, because it was impossible. Well, we achieved it, and we achieved it several years ago, probably 2 years after he said that. So that's something we must recognise. We have a very strong NBN partnership. It may not feel like it at times, but there's actually a huge diversity and wealth of bodies around the NBN partnership, and we've got to think about that. Data's now being used in ways it never was before, and some of the examples on the slide there you can see we can actually publish and underpin credible world-class indicators because we have the information on which to do that. And more importantly, perhaps from my perspective, we as agencies, and no doubt you as recorders, have got a better idea what it is you want out of this. What are the species that are really important to focus on? All this has came out over the past 10 years probably. Now the sort of challenges we need to be quite clear on as well is that we're still dealing with a bit of lack of join-up. We're still relatively loose around standards and focus. There's still a lot of competition, internecine warfare. One of the examples I would use there, many of you probably saw the Michael Palin, his travels in Eastern Europe, where he went to a place called Chop in Hungary, where to move from one station to another station, the gauge of the railway line changes. They have to move the carriage. And that's where it sometimes feels we are. I can't just go to one place to see all the information on common frogs. We have to adapt it and modify it from a range of sources. That takes effort, it takes money, it takes your money. I want to be in a position where we don't have to do that and we can reinvest that money in something much more positive. Data restrictions, there's still a lot of debate and understandably some concern in some areas about making data, making records available rather than the information. I would like to move to the point where we're a bit more relaxed about that and we actually focus on the interpretation of that data rather than the data itself. There's lots of high overheads. You may not be aware, and I'll mention this figure many times, but between Natural England and Environment Agency, we actually we pay something of the order of £800,000 a year to support record centres in England. Most of that money is actually around data management, and 39 different data management systems. I would hope at the end of today, when you've seen some of the options on the table, there are better ways of doing that. And although that money will have to be less in future years, the bits that are not being used for direct traditional data management can be reinvested in some of these other issues. Most importantly, we're not making the best of current data. We all know that, and there's lots of efforts going on now to try and do that. And more importantly, plug in the last point I made in the previous slide, is we do need more experts and we do need more people contributing. We do need new people coming into it. And again, there's lots of things you'll be seeing today that will take you there. Now let's try and move a little bit to the future. This is quite speculative, and in some ways it's actually quite controversial, but from my perspective, it's fairly simple. My starting point is I would like to see us being simplifying and speeding up the flow of data from when it's collected into the field to when it's made available for whatever use, be it by the recorder or by a national agency or whatever. The speed there is quite important. There's a little example of a thing called the North American bullfrog, which is classic of any non-native invasive species. If we'd have known immediately or within a week of when it turned up in the wild when someone released it, we could have gone out and took it back into captivity, to put it kindly, or shot it if we couldn't. But the point being, we didn't know. They then multiplied to such numbers that it's cost us hundreds of thousands of pounds to actually get on top of North American bullfrog. So the real benefit here is we do want to get these simple, fast flows of data so that we can deal with these issues when they're dealable with, rather than having to cope with massive problems later down the line. So the first one we're talking about here is what I would call simple data flows. And by that, I mean, I've just had some very bitter experience in my day job having to try and collate all the data under the Habitats Directive 6-yearly report. And just simply amassing the information on the common frog, as a good example, was a nightmare. It took us months and months. It shouldn't do that. That's your money you're spending with my colleagues having to collate this data. It's money that's wasted. You know, I don't want to see us getting there. As part of the data flow, basically what I'm interested in is simple ways of putting data in, simple ways of verifying that data when it's there. We all make mistakes when we enter records. I'm the first to put my hand up. We need to make sure, and we need to learn from those lessons. And the third principle really is about that getting it in one place so as we can access it. So empowering the recorder is a key part of the vision in the future. And a good example of that, those of you who use the, apologies Andy, those of you who use the bird track system will understand what I mean. You get ready instant feedback. It manages your data. You don't have to hold a little shoebox somewhere. You can get access to data when you need it, and et cetera, in a much more user-friendly environment. That's the sort of thing we're looking for. Improving that quality. We've got to make sure that the data that actually ends up being used, we're credible and we can stand behind that identification. And again, examples like iSpot are a very good example of how that validation works with relatively new entrants to recording. We've got to think about responding to these changes that are going around. And some of those are simple because we have automated ways of checking whether your record is actually within the range of the species, whether it's actually in the North Sea and it should be in the middle of Epping Forest. And all those things which we all do routinely. We're human beings. So that's what we want to do. The changes that I've talked about already, we do want to reduce those burdens on getting the record in. We do want to look at how we then manage and support recorders. We do want to see how all the systems work. And the final point here is really the vision we're looking for is to give everyone greater security of knowing that they're not going to have to spend the next 9 months fighting for the funding for the year after, so as they can then fight for the funding for the year after. We've got to break this vicious cycle. We've got to give you more security. And that comes back to the government's pledge that it recognises the value of volunteer recorders, and it's actually putting some weight behind trying to do something about it. So very briefly, what's actually going on now? The first thing, as I've already mentioned, are these principles and standards. They're very simple things. I'm just a simple chap, and if you can think of it simply, it's easy to deal with the complexities. So there's these basic 3 principles in my mind. There's the easier input. We've got to be thinking whether or not we want it. We're going to be moving to online type systems, mobile or desktop, but we're going to be getting easier input. We want easier validation. We've got to find better ways of helping all of you to contribute to that rather than sending you to 300 places to check records. And we've got to have efficient access. And the NBN gateway, I would recommend, is that way. And the whole of that principles and standards is actually being overseen and guided by the NBN partnership. The NBN Trust provides the heart of the manpower and the woman power to do that, but it's that partnership and that framework that's going to deliver that. Online recording tools will ultimately be the norm. The point I've made about, just for 2 government agencies, £800,000 a year for data management is an awful lot when you could simply have a much more simplified system. And most importantly, that validation and verification, there's lots of best practice out there. Many national schemes and societies, many local record centres have their own little suite of validators. We want to find ways of making that work across the piece. Now, the other thing is, the other side of that is there's lots of things happening in terms of funding. We have the DEFRA fund for volunteer recording, which Natural England administers, and there's a whole raft of other projects funded from that same pot with JNCC and Biological Record Centre that are we're all working together to improve the support that recorders are able to tap into. Now, existing approaches are not really balanced across taxa from our perspective. You know, we can do an awful lot with birds and plants and bats, etc., but we know virtually nothing about many of the lower plants. We know virtually nothing about invertebrate groups. Therefore, we do need to try and balance that. So one of the things we're doing, which is actually this diagram, is we're trying out a new approach. Is rather than take it taxon by taxon, we're trying to look at whether we could establish a network of stratified samples, rather like BBS squares, across England, where we actually look at multi-taxa recording against biotopes. The first one we've been running, it's now 18 months in, is one called PondNet, looking at small standing water bodies, where we're getting pond conservation to champion and lead the whole community of taxon societies with an interest in ponds and species in that fresh water. And we're running those pilots now, and hopefully that will give us lots of learning lessons that we'll be able to roll out wider. We've also just let the first stages of the contract for the same with Lowland Heathland. So those are some of the new approaches. The volunteer support side, we've talked about the DEFRA fund, and there's a little display outside about the DEFRA fund, which we're trying very much to deal with strategically and try and win the war rather than win a few battles by just giving small grants. And my colleague, Andrew Thompson, who leads that project, no doubt can tell you about that today. Now, the real changes, I think, are going to come around some of the challenges which we're throwing out, particularly to national societies and record centres, in the sense that if we move away from data management as a core function, where does that leave people? Well, it doesn't leave you hanging over a cliff. One of the real things we're looking at here, and what we'll be doing with our record centre colleagues over the next 4 months, 5 months, is to try and talk through how we can encourage more online recording using the record centres, how we can get more volunteer support locally through those record centres, how we can engage record centres in habitat surveillance, which is a whole new ball game, but critical to biodiversity recording. And similarly, there'll be similar discussions, no doubt, with national schemes and societies. So how can you help us improve this situation, take these opportunities and make the most? Well, first of all, there are lots of discussion forums about now. National societies, the NERC, NBN fora, are all going to be debating some of these principles and some of these standards around these new approaches to biological recording, or best practice approaches. They're not all new. We really want you to think about where you want to be in your taxon group or your sector. What do you want to get out of this change? What are the real problems you've never cracked? Let's make a chance at breaking some of those down. Most importantly, you've got to recognise the opportunities. You've never had stronger government support than now. Never. You know, 27 years in nature conservation agencies, I've never seen a better time, and I'd say that most sincerely. So we've got to use it. The National Biodiversity Network is the glue that will make this work, but only if you use it. We don't want incompatible glues here. They've got to be coming together in one place. Immediately, I think what you should be thinking about are some of these principles, those simple things that we need to get right and agree on, and then we can move forward. These will be advertised through the usual fora, but they are about consistency and simpler ways of dealing with work. And most importantly, it's your data. If I want my data to work harder, I'm sure many of you do. There's the famous phrase of collect once and use many times. But I really think we should be giving you more views of how your data has made an impact and made a difference. And that's something that we'll be trying to help you with. So briefly, in summary, the first message, the key message is that change is inevitable. It isn't something we should be fighting. It's always changing. It always has changed. Let's embrace that. Let's get over it and let's move on. We do need to agree on these core principles because as a community, we do need to have some standards. We want to make sure that our train can go from that station to that station without a 4-hour stop while a crane lifts us. We've got to use these opportunities to explore change because these opportunities will disappear unless we do explore it and start to begin to show some benefits out of this, both to ourselves and to the funders and to the public. We need more recorders. There's no doubt at all about that. We must be far more ambitious than I think we have in the past. And of course, we need to get that data, using it more. One of the things I haven't said, and I'll leave you with, is every day, Natural England gives £1 million to farmers. Over £400 million a year we spend in agri-environment at present. And that might be true in the future, where Mr. Cameron's negotiating very hard to allow us to do that after 2013. My point is, that £400 million can be spent very blandly with a few things we can put in and we can gang more heathlands, or it can really turn around biodiversity. And the thing that makes the difference is essentially your data. So I'd like you to use this as a basis when you're listening to most of the other presentations today and think about where it takes us. So thank you very much indeed.
Thank you, Keith, for a wide-ranging, coherent and inspirational, thought-provoking talk. Do we have any questions for Keith? Lull them. Good. Thanks, Keith. Okay. Our next speaker has taken us to a new place in terms of biological recording. She's been helped by one or two of us, but I think the drivers come from her. And I want to introduce Linda Davies from Imperial College, who is the inspiration behind the OPAL programme. And you're going to talk about anyone can send in records. Thank you, Linda.
Yeah. Thank you. It's going to take me a few seconds just to move over. While I'm doing that, I'd just like to say thank you very much to the NBN for this wonderful, they're putting it up automatically, wonderful opportunity to share with you some of my experience of recording as the director of OPAL, as a member of a society, the British Lichen Society, and as an active member of my local community. What I'm going to do is just give you a tiny bit of background information and then talk a little bit about the OPAL programme, a small case study based on the British Lichen Society, and then talk about my main interest, which is in widening participation in monitoring and some of the challenges associated with that, which resonate with some of the things that Keith's already said. And the basic concept for me is that it shouldn't only be scientists and government that are involved in monitoring, but the wider community, and particularly young people. And this, some of the illustrations here go back to a piece of biological monitoring work that was done by school children aged around 10, 11, 12 back in the 1970s. And they were told to go out and record from rivers and to record to species level both fish and aquatic invertebrates. And Mellenby, the editor of the journal, wrote in his editorial and in the paper that the data mirrored that of published studies. Now, okay, there are uncertainties, and we're going to talk about those today, but I still think it's very important to think about the value of data being collected by the public for several reasons. In particular, obviously, we're concerned about the environment, and all of you are aware here of the convention and protocols since Rio at +20. And it's not obviously just about surveying and documenting biodiversity, but it's also about sustainable use of land, air and water, and taking the public with us, education and so on. And this idea that that's much more than a government responsibility, everybody should have a role to play. And I don't think we've been very good at giving the wider public that role. And as well as the environment, in recent years, and I think it isn't very much in the last 4 or 5 years, it's been recognised that it's important to the public to be involved and connected with nature. We've seen them move so much further away from it through urbanisation and many other reasons. So we know that contact with nature is important for good physical and mental health. We know it's important for childhood development. We know it's important for community cohesion, and I could go on. And I think many recent papers, the National Trust and other organisations, are trying to illustrate how much still needs to be done to reconnect people with nature. So, OPAL objectives, very much along the lines of getting people involved, and we focused on areas of deprivation and people, minority groups with our work. So getting people outside, great environmental education program using a lot of the new technologies. We wanted to inspire a new generation of recorders. We wanted also to try and support collaboration between the statutory, voluntary and community sectors, and in the OPAL partnership you'll see we have a lot of the big players all working together to deliver the program, and of course we're interested in the results. So OPAL, as a partnership, is set up with 3 core components. The first here is the national network, and this is a university in each region of England, and we have an expert team within the university, and they work with local people through the role of a community scientist, a sort of post that we introduced. Community scientists, possibly a PhD student and some volunteers, will go out into the community and work with local people on topics of relevance to that region. So, for example, the University of York are working on brownfield sites. Nottingham are looking at heathlands. University of Herts at loss of orchards. Imperial College London looking at the urban heat island. Supporting them, we have the national centres. So 5 expert groups who, again, carrying out research and education programmes, but involving the public in every step of the way and covering our basic topics of soil, air and water and climate. And then on the biodiversity front, obviously more relevant here today, the Natural History Museum leading a big programme on taxonomy and the Open University developing iSpot. And the third core component are the support services, because if you're going to work with the public, you need strong communication. And we have the portal and the database based at the museum and a communications officer who's working full-time to promote the OPAL programme. Field Studies Council have led the schools programme, and field packs have been designed by them as well. And then the NBN recording software, Indicia, and mapping software as well. And the parks have done so much of the things that parks do well, which is working with local people. We have 2 associates, the agency and DEFRA. But the glue that holds us together and makes the programme a national one are the national surveys. And we've designed 6 of those so far, and we have number 7 coming out in May of next year. One of the schemes that we run within OPAL that's relevant to most people here, that's been administered by the Natural History Museum, is the Small Grants Programme. And it's been extremely one of our most successful projects. And at the beginning of this scheme, we put £500,000 up for this scheme. They put forward, carried out a consultation to see what would be helpful to natural history societies. And 19% of the people they got in touch with responded. I remember they got in touch with over 800 organisations, but only 19% responded. 81% did not. So I think that's an important statistic to remember. But of those that did respond, what a lot of them said they needed, or what you said you needed, was more members. And I think that, again, agrees with what Keith has said. And there are a lot of other things that societies asked for. And so the scheme was designed so that we could offer small grants to help societies get the things they needed to particularly try and improve membership. And so far, the museum has awarded 96 small grants, totaling just over 200,000. But they have other things going on. It's been a big programme. Nature Societies, Nature Groups near you, slight change of name, is a new directory giving all societies an opportunity to have a web page with information that can be, that people can find you and you can find each other. I think that's a fantastic new resource for next year. And there have been many other resources for teachers, a lot of publicity, and the events like Big Nature Day. Now, going on to this case study, talking about the work of the British Lichen Society. And that was founded back in 1958 with 25 founder members, and they now have a membership of over 650. 50% of those people coming from overseas. But I think it was interesting to look at the objectives they set then that are still highly relevant, teaching, public awareness, as well as conservation. Now, getting lists together, so it wasn't until the Society was first formed that they started to share records and we got a picture of what was going on at the national level. And then, as early as 1963, Mark Seaward put together the mapping scheme, and that for the first time allowed people to send in little record cards and the distributions could be mapped. But moving on, as has been said, to the 1990s, we see the first computerized database, BioBase, and then as we went into the 2000s, recorded 2002 up to recorder 6. And an amazing commitment by members and by Janet Simpkins, who's here, who's led all of this work, to get the Scottish records digitised in 2003, and then to work on all the paper records for England and Wales as well, and get those digitised by 2012. And this year saw those records go onto the NBN, a huge 1.2 million records, which is an amazing achievement given the scribble of some of the records and so on that people have had to deal with. So we don't just have those 1.2 million, we also have Mark's mapping scheme on there, and that covers over 2,000 species of lichen. And I was looking at GBIF, the Global Biodiversity Information Facility, last week, and of the 34,000 records for one lichen, Xanthorrhoea parietina, 23,000 come from the UK. That's on the global scale. Now, we know that's not proportionately correct, but nevertheless, it's a fantastic achievement and just shows where the UK is with all of this. So data's a massive issue, and there are a lot of costs associated with what the Society has done, hard work into raising funds, as well as the Society putting up its own money. And this issue around shall we share data or not, which I think was a big debate 10 years ago or so, but now is not such a problem. Particular issues that the Society's had to grapple with, well, they must make sure that the data is appropriately validated, and so the rare and scarce species are still will go through expert review. But there are other tools that can support them, such as the new data cleaner. Recording bias, again, always a problem. And there's one site that's been recorded more than anywhere else, Traplain Law in Scotland, and it might not be a surprise to some of you to know that that's where our top recorder, Brian Coppins, walks his dog. Now, interestingly, I've put here 50% of records, of those records are collected by just 6 recorders, is actually around 40%. But the point to make is that around 99% of records now are coming from just 30 active recorders. That's a very small number when you look at how many records we have. And is it cause for concern? Janet tells me that as we've got more computerized, we have better recording facilities, the number of recorders is improving. But it still is a big challenge. And BLS are still using paper-based records. That's because there's so many species, I think, on over 2,000 species. We have a system, a numerical system that's working well. So how have we worked through OPAL with the British Lichen Society? They have been there every step of the way, helping us with the research questions, through the design, with the training, and in every other aspect of promotion on the radio and so on, and turning up at events to promote OPAL with all their equipment and their enthusiasm. That's been brilliant. For those of you who haven't seen the survey, just a quick introduction. It's about the relationship between air pollution and biological diversity, and we're using nitrogens that are now sensitive to eutrophication, well, sensitive or tolerant of, rather than, say, 30-odd years ago, when there was a children's survey on ones that are sensitive to the then acidic conditions. And you can see as people send in their results, we can map them and feed back to them and say thank you. Now, what we do with each of the surveys, we produce 20,000 packs that go directly into schools, and the FSC manage that programme, and then we have 20,000 that we distribute to the people across the regions, and this is done by each of the universities. And the British Lichen Society provided a lichenologist to us, to the community scientists, wherever they were working. And particularly difficult sometimes in these hard-to-reach areas, but we always had their support, that expertise and that monitoring of our staff, and also other people, local people coming to recording for the first time. The school that exhibited here at the Royal Society Summer Exhibition this year, their exhibit was about lichens and air pollution. And they learned about that topic through OPAL, through the work we had. They got in touch with us to say, can you help us design a research project based on OPAL? And the British Lichen Society and Natural History Museum worked with those young people to get them to the stage where they were then selected to be the school that worked, that exhibited here this year. So a huge impact, I think, from what we've been doing just with this project. But the BLS have gone on to do more things that not funded by OPAL. They've been starting training courses for beginners, and they've introduced the Next Step programme to take people onto perhaps another 20 or so species. And what I like so much about that, the design of that project, is it not only takes them on to deepen their knowledge, but it introduces the recording card. This ongoing support has been very important for OPAL. And I thought it would be nice to hear a little bit from some of the people who have benefited from that expertise that natural history societies generally have provided. I think the Yorkshire Naturalist Society, but many of you here have given a lot of time and support to OPAL to allow us to embed it into the community. So that's just an example of some of the people that we've been able to work with, and some of whom we hope will go on to be recorders of the future. But it's just wonderful to see how much pleasure they've got out of just learning to go out and name things and get it more involved. Again, the impact of OPAL generally, some of the stats we've got from our website, 3,700 people have responded to a questionnaire that's given after the lichen survey. And 50% of them had said they couldn't identify a lichen before, but 87% said they'd learnt new skills and 92% had learnt something new. And I think that, again, degree of learning is very important, and it's mirrored through the work done by our social scientists, through interviews, and also by the results from the other surveys. What we're also seeing is a change in behaviour. And that's quite difficult to measure, but again, we have quite a bit of evidence arising now that going out and doing these sorts of activities is changing the way people think and feel towards the environment. But more importantly, people are finding it fun, and it's taking part in research has been a key motivating factor for a lot of people wanting to help with OPAL, particularly the schools. Teachers had not been doing as much outdoor learning as in the past, and it's giving confidence to them. But we're also recording improvements to people's health, and certainly in terms of community cohesion, and we have evidence of that. So all these records, well, what are we going to do with them, and how useful are they? Well, we've got just 4,000 sites surveyed via the lichen programme, but from our evidence, we know that about 4 times as many surveys have been carried out. But we're having a problem in getting people to put their data into the database. Half of our data is coming from school children. I think that's a good thing, but if we're looking at data quality and confidence, then that's something that one needs to be aware of, but that one can deal with. Identification, lichens are hard to identify, but when we did some validation work with the public, 95% correctly identified Xanthoria peritinus. So, you know, it's not, it depends on what you choose and what you ask the public just to record. We haven't analysed a full data set. We expect to publish a paper next year, but the Soil Centre, who have asked the public to do, all our surveys are around more than just biological or recording of wildlife. They also include information about habitat. And the soil survey was asking people a lot of information, to gather a lot of information about soil, which would be the pH, the colour of the soil, the smell of the soil, the texture of the soil, and so on. So a lot of information that is quite reliable. And they have analysed their first 4,000 results. And the results broadly follow the same trends as data that's held by the BGS and the Environment Agency. And they've found a lot of correlations within the public data sets that they've found interesting and gone to investigate further and carried out more work so that the public has directed them, if you like, towards some areas of research that has proved to be fruitful. So there are a lot of good things associated with the soil survey in terms of the science, but also it's raised awareness of the importance of soil and soil research. A lot of publications out from the soil team. But in terms of data quality, there are a lot of things we could do, and we've learned a lot of lessons through OPAL. things we can do to minimise error. And of course, we now have tools like iSpot, and so nearly 1 million visitors to the website there. That's hugely important for identification, and in the future, of course, we're going to have the molecular work, sequencing and so on. That will mean that identifications are not the problem, although that's some way off. Huge amount of help with recording out there, and in DCIA, again, a fantastic new tool, great kit for people coming to recording for the first time. But there are many other things, photography, we can rank people's expertise, use numerical data, but critically, of course, it's the source data and ensuring that whatever data sets we gather, we demonstrate the source of those data through the sort of metadata records. And then we've got new technologies. We're preparing our 7th survey at the moment on the topic of tree health, and one of the staff at the museum, Chris Howard, put together or did a review of apps that are out there related to trees, and there are literally hundreds of them. And some of them are just fantastic in terms of the photography. There's the imaging one that you can just use to photograph the leaf on the tree, and it'll try and identify that leaf for you. That particular app's an American one, but it's being adapted by the museum for release next summer, which will be nice and timely for the 7th survey. But you can also record your grid position, of course, and you can send in your records. So a lot of support there. So in summary, local knowledge is very important. I think it's very important. I think we need to think about how we get it and how we use it. But it's clear that it's fun. We all know it's fun to get out and record, but it's also good for our well-being. I think all sectors of society should have an opportunity to play their part. And I think we need to think much more broadly than just recording biological data. And as Paul Rake said in the video, it makes him feel valuable. People want to do something. They want to make their contribution to conservation. And I think we need to try and facilitate that, and recording is a great way of doing it. There are lots of things we need to think about in terms of the confidence levels of public data, and I think we've identified some of those already this morning. Keith has, and I'm sure we're going to hear some more. And I think there are some future challenges that we need to think about in terms of where those data should be stored, accessibility, feedback to people. People send their records, they want to know, the public, what they mean. So if you're asking them to send something in, we've got to have a mechanism where we feed back, and we've got to make sure we analyse and use those data as effectively as we can. So really, just to wrap up, to mention that OPAL officially, its 5-year programme comes to an end next Friday. And the evaluation, we've carried out an evaluation, and we'll be publishing our community environment report in January. But we still have some things running, a sort of skeleton programme, which includes the 7th survey on tree health. And we're working with Faroe Forest Research and a number of other organisations to try and link the problems we have with pests and diseases to that tree health survey. There's also, we're looking at whether we can find a way of establishing OPAL as a charity or some other NGO. That's very early days there. There's some developments in trying to get a strategic or strategy together for Europe on local knowledge, how we gather that and harness that. And there's similar initiatives going on in the States and in Australia. So I think, as was mentioned by Keith, we need to look at coordinating this information, coordinating and developing a strategy together. And I'd just like to thank Janet Simpkins from the British Lichen Society for providing me with the basic data from there, and Barbara and Pat, who've been such great support to me. To thank our funder, Big Lottery Fund, and to also recognise the importance of the partnership that delivered OPAL, including the NBN, Natural History Museum, the Open University, and all the other organisations, a lot of which who are not here today. But it has been a partnership that has facilitated this level of engagement. And also to all of you Natural History Society representatives who've made it such a huge success. Thank you.
Well, thank you, Linda, for reminding us about about biological recording in a broader context, the repairing the disconnect between society and wildlife. Are there any questions?
Simon Pickles from NERC Ecology Centre. I was wondering what commitment the universities who've been leading the various areas have to continuing to be engaged following the time when money runs out.
Yeah. Are you working with the group in York University?
Yeah.
Yeah, okay. I think there certainly has been support from the university at the senior level. Brian Cantor, the they called Vice-Chancellor, opened one of the OPAL conferences a couple of years ago, and he really is committed to involving the public in this way. So I understand that there is support, ongoing support from York, which is fantastic. It's not the same in all of the universities. I know there's some issues around, particularly with Newcastle at the moment, so very patchy. But you'll be okay, I think.
I haven't seen any signs of it yet.
Oh, really? Okay. Well, yeah. I think there's no responsibility within the university to do this, but I think obviously there's an understanding that in any research programme, if you're applying for funding at the moment, that you do need to look at the impact of the work you're going to do. So there's a sort of route through that route there. But responsibility also lies through programmes like Access, to ensure that you have the sort of students from different backgrounds getting into the university. And there are a number of different routes the university could think about in funding, but personally, you're absolutely right, there is no commitment from any of the universities to continue this work. But there is some goodwill there that we hope will generate some continued involvement. Sorry, there were... Yeah, I agree. It is a real problem. I mean, with OPAL, we had a strategy that when people send their records in, we give them some feedback which might indicate that, okay, the lichens that you've found are indicative of a polluted environment or whatever. So we think that mechanism of feedback is absolutely essential, especially for schools. And then we make the data available so schools can download graphs and so on. But in terms of strategy, yes, it's one of the big issues I think Keith would recognise, everybody would recognise. We need to look at how we're going to store and give access to and thank people for their contribution if we go down this route. I mean, people are going down the route. As you say, there's all sorts of apps coming out for recording things, but I do think we have to think very carefully. Otherwise, we're going to alienate the public. It might be a little bit like the beginnings of recycling, where everybody were put off because they didn't have the sort of quality that we now have from recycling. So yes, it is an important issue. Thanks. There was one more.
Can I ask you a question?
Yes, sorry.
You spoke about OPAL in terms of where it might go in Europe and other. You said nothing about Scotland or Wales.
Oh, well, Scotland are absolutely committed. They're rolling OPAL out across Scotland through the BTCV. They looked to see if they could find some programmes. And no, the SEPA are very keen to work with everybody else at the European level. Yeah.
Charles?
Linda, if I can pick up on one of the figures that you quoted, which was that 99% of the records coming into DLS were from 30 recorders. Now, the immediate response to that is echoing Keith's plea that we need more recorders. But to turn it on its head, I'd be interested to hear from other people in the room. How many committed and knowledgeable recorders does it take to run a good national scheme? It looks as though you can do it with just 30.
Yes, but to keep those 30 active and involved, I think is quite hard work. But absolutely, I mean, it's open to the floor if we've got time. It's a great question.
I'd never look at trap frame law again with the same eyes, that's for sure.
Janet?
Can I
yes, of
pick
course.
up on that? Speak for the if you can run an active national recording
The full data set hasn't been analysed. We have taken a look at the records just from oak, and that's indicating that the diversity of lichens, no, let's just say the lichens that are tolerant of eutrophicated conditions, and particularly interesting in the cities, are the records, the greatest number of records are coming from inner cities. We know that. It's what we expected, but it's great to have it confirmed by the public. But also the general public have found species in cities that we didn't expect to be there. So I think what we've learned is that some of the species that we thought were going to be sensitive to nitrogenous compounds are not as sensitive as we expected. So we are learning things, but I think it is quite concerning that even with the small number of data sets we have on oak, to see so many species that would normally not colonise oak there as well. So that we're changing the substrate of the bark pH and so on to through pollution. So I think, yes, we are learning some new things, but generally the public data is validating what perhaps we've seen from publications. So there are two things there. Some new information from the soil side. I think certainly they have learnt, identified some correlations between pH of soil and certain earthworms and that they hadn't expected. And so again, it's directed research as much as answered or provided new answers to questions that we weren't expecting.
Time for one more question, or what, at the very back?
And perhaps just to add to that, we ought to say to the BBC that where they're promoting some of these national surveys, maybe when it gets to the following year, they ought to include some of the results.
Yeah.
Okay. Thank you.
Thank you, Linda. Do I just press this, the on button to make it move on to the next one? Right, I'd now like to call on Michael Pocock from CEH to talk about citizen science and its role in policy research and engagement.
Does it just come on?
It should. Where's Trevor disappeared to? Do we just press the on button with this?
Thank you. Well, thank you very much for having me. I'm going to be covering, I suppose, similar sorts of themes to those covered by Keith and Linda already, but from quite a different angle, so you can do a bit of comparing and contrasting between us. So I'm going to be talking about citizen science. And there's a real buzz about citizen science at the moment, and citizen science falls within this big sort of ecosystem, this environment of participatory research, engaging people, volunteer-led monitoring, open science, street science, a whole load of things like that. It's a really exciting place to be, and there's, as I said, there's a real sense of buzz. And just if you have a cast around and look at the sorts of projects which are going on, these are just some primarily from the States, which have been picked from a repository of citizen science projects. There's a huge diversity in terms of the sorts of projects which have been going on. Some look very scientific, some look a bit crazy, but there's a whole load of different things which have been going on, ways of engaging people with science. Many of these projects are very, very recent. Many of these projects are also quite specific in what they're trying to aim to do. But there has been increasing sense recently, particularly in the States, of bringing together not just specific citizen science projects on particular themes, but trying to bring things together more generally. So this is exemplified by this project looking at Californian biodiversity. So this was launched this year with great excitement. That this project will be looking for evidence of changing distribution patterns of plants and animals and their potential drivers. So this real buzz about engaging people with their environment, engaging people with science, is sort of drawing together into trying to do something much bigger. Now, sometimes when I think about and get caught up in the buzz and the excitement of this sort of thing, I just sometimes feel like history is looking over my shoulder. So that project about biological recording in California was launched in 2012. But of course, biological recording in this country goes back a lot further. You've got John Gerard with some of his earliest records of plants, John Ray, the father of natural history, and the recording that he did, plant recording in Cambridgeshire and across the rest of the country. And I think it really does demonstrate the huge legacy and the huge history that we've got of biological recording, which has gone on from these very early natural historians. And then you've got the Victorians and the Edwardians with their incredible amounts of work and field work, going out making county floras and faunas, covering a whole range of different taxa. Then there was the monumental work which went into the first Atlas of the British Flora 50 years ago. And it's just remarkable thinking of the work that went into that, but also the production of this atlas 50 years old this year. Obviously that carried on to 10 years ago, the new atlas, and then we've got the online ways of looking at the data. And so you've got this, certainly in this country, this huge legacy of biological recording. But you can contrast that with this buzz of the modern, the flashy, the citizen science. And I wonder how you see these two interacting. I wonder whether you're like, just in the top left there, where you're a biological recorder. And this whole citizen science thing, well, it sounds rather too American. And rather too buzzy and rather too trendy for you to even really want to utter the word citizen science. Maybe you see it as two completely separate things, that there's biological recording and then other people do citizen science. Maybe you see it as there's a bit of an overlap. Or maybe you see it as biological recording existing broadly as a subset of this big thing which is now being branded or being called citizen science. Well, I'm going to be taking this sort of approach as I go on. I'm going to be looking quite broadly at citizen science, but that does encompass a lot of biological recording. And I think one of the key things is that I know the term citizen science is not universally popular, but if we don't recognise biological recording as falling under this banner of things which are called citizen science, then I think potentially we're missing a trick, because others can see it as citizen science, and if they don't, then they really ought to, because I genuinely think that within Britain, our legacy of biological recording is huge. The lessons we've learnt going back decades are enormous, and if we as a community don't interact with those people who are flying the flag for citizen science, then I think we're missing a trick, and I think they're missing a lot as well. So I said about citizen science has increased recently. There's been this buzz, there's been this excitement about it. So why has it increased? I'm going to go through 4 reasons. I'm sure there are more. I think the whole communications technology has advanced and has changed. So we've moved on from this a way of trying to promote surveys or promote volunteer participation through magazines and asking people to cut out the forms and fill them in and post them in. We've got websites, we've got smartphone apps, we've got social media, and that's made it a lot easier to promote projects. It's made it a lot easier to collect the data and to use the data as well. So the second thing is, and Keith touched on this, I think there's an increased trust in the data. The fact that volunteers can collect data which really is useful and really is relevant. And I think particularly the use of volunteer collected data in these headline indicators of biodiversity is a really, really good example of that. And of course for scientific research as well. There are probably literally hundreds of papers published each year which rely on volunteer collected data. Thirdly, I think we're all facing, as a world, as a society, we're facing big challenges. You'll often hear about them in terms of challenges of food security, of ecosystem services, of climate change, these sorts of big, big questions. In order to answer and try and address some of these problems, I think we need data at very large spatiotemporal scales and also at very fine spatial-temporal resolutions. And just shown here is the distribution of Himalayan balsam at a global scale with primarily volunteer-collected data, and at the scale of the Cotswold Water Park as well. And I think that demonstrates the two extremes at which citizen science data can be valuable. And I think the fourth aspect is there is this desire to engage people. And so I've come into citizen science from a university research perspective. And clearly there's been this desire over the past couple of decades for researchers and scientists to come out of the ivory tower. And there's been a real desire amongst many people that they want to do that. And initially this was termed with regards to communicating to people, talking to people about science. And that's transformed to becoming more about engaging with people, it becoming more of a two-way dialogue. I became an ecologist partly because I care about the natural world and because I'm passionate about the natural world. And I recognise the fact that I don't want to just chart the course of doom as things get worse and worse. I would like to help to be part of the solution. And I realised that people are involved in that, helping to bring about that solution. And for people to help in that process, it's people's behaviours and ultimately something inside that needs to change. And I think engagement with nature is a really valuable way of helping that process. Just recently, I've been involved in an overview of citizen science, and this has been a project published by the UK Environmental Observation Framework and it was led by Helen Roy at CEH, with some other colleagues from CEH and the Natural History Museum as well. There were three main components to this project. We were looking at a systematic review of citizen science projects. We looked at a whole load of case studies in detail, and we had interviews with potential end users of the data. And I realised that in the audience there are several people who took part in one of the last two components of that. So if you did, thank you very much. One of the outputs from this project is this guide to citizen science. And I've never been involved in a launch before, or launched anything quite like this, but today is the launch. This is the launch of this guide. And so you're very welcome to go at the back during lunchtime, pick up a copy of this guide. The aim of this is it's a practical how-to guide for thinking about citizen science generally. We drew on our experience and we drew on a whole load of evidence that we collected as part of this review to bring this together. And so it would be great for you to use it and to let us know what you think. Good, and also give us your feedback about areas which we can include maybe in future versions of this as well. But we really hope that this will be something which can really help improve citizen science generally, I suppose, in terms of providing this how-to guide. So I said that one of the lines of evidence which went into this guide was this systematic review of citizen science projects. And so what I did took me quite a long time, was I looked at over 250 citizen science projects which are currently extant. And I scored them against a whole load of different features. The lead partner, what their aims were, what the scope of the project was, what sort of data they were collecting, how they were collecting it, a whole load of things like that. So I did that for each one of these projects. It took me ages. Clearly, that's a huge mass of data. And what I wanted to do was I wanted to try and understand the variation across the whole range of citizen science projects. So I simplified the data down. I did effectively a principal components analysis, if you're familiar with that. But I simplified the data down to the two most important axes. And so I could look at what the landscape of citizen science looks like currently. And that's what it looks like. Which in and of itself is not hugely informative. Although one of the things that I think is really striking about this is that there aren't particular clusters of different types of projects. There's a gradation across the whole range. So I will explain this in a bit more detail. So that first axis, the horizontal one, is, and this is what came out of the analysis as one of the most important variables in explaining the variation across these citizen science projects. So it goes from the mass participation projects, those where people can take part anywhere, anyhow, very easy to take part, there's support via websites, that sort of thing, through to the much more carefully designed scientific studies. Often there's repeated sampling, often it's more local in scope, may require special equipment, and often personal training is given or is available. The second axis is a bit harder to pin down and to summarise. But it sort of goes from the sorts of projects where there's high investment, high return, so there's lots and lots of rich supporting materials which have been developed, and asking for lots and lots of different data, different types of data, asking for measurements and counts. And then there's the projects which are lower investment in terms of their presence out there in terms of websites and things like that. And the data which is required and which is asked for is much simpler. Typically, it might be presence or absence of things like that. So that might be a bit tricky to sort of visualize where things fit across that. So, and I'm doing this with slight trepidation. I was slightly cautious about doing this, but what I wanted to do was to try and exemplify the sorts of projects which exist within those different quadrants. So, read the small print, please. It's just a generalisation. I'm not particularly endorsing any project one over the other. There are other project providers which are out there as well. So there we go. I think that covers everything. So going through these quadrants, you've got the sort of projects which are typified by the OPAL type of projects. Mass participation, let's get out there, let's get as many people involved as possible, but let's ask them to do something really quite detailed, with maybe detailed protocols, packs which you can download. It's that sort of project. You've then got more structured surveys, things like WEBs and some of the other BTO surveys would come in there as well, UK Butterfly Monitoring Scheme. These are the sorts of projects where people go out, they often do repeated surveys on a particular site, they do counts, they do quite detailed analysis. And then there's a whole load of recording schemes, which I guess is typified by many of the biological recording community represented here, which sort of, I've used the Biological Records Centre logo to exemplify that. So typically these are much more local, they might be much more personable, there may be training courses and mentoring provided. The data is often simpler in that what is returned is things like lists of species for a site. There's not often, this isn't always the case, but there's often not lots of other supporting details about the site which go and are captured as part of these biological recording schemes. But clearly the data is hugely valuable. And then there's the whole other environment of exemplified by the smartphone apps. People can whip their smartphone out their pocket, take a photo, do their science, move on. Very quick mass participation ways of engagement. So I'm going to spend a few minutes, if you will indulge me, to talk about a project which I've been involved in, which is Concrete Science, which sits in that part of the chart. So Concrete Science was a project which I have been running with Darren Evans from the University of Hull. And I think one of the key things we felt about Concrete Science was that it was a hypothesis-led project. We had particular questions which we were interested in. We could only address these questions by drawing on data from across the country over the course of quite a long period of time. In order to do that most effectively and most efficiently, we needed to engage lots and lots of people. So we worked hard at engaging lots of people. We received a huge amount of data. What we wanted to do was we wanted to do real science and we wanted to do really good engagement as well and have those two running absolutely hand in hand. So Concrete Science was all about this rather attractive but rather destructive moth, the horse chestnut leaf miner. It's got caterpillars which live inside the leaves of horse chestnut trees. I'm sure you're familiar with this, but I'm getting into my school group spiel here. So they live inside the leaves, eating them from the inside out and causing the leaves to go brown, and often the trees go brown by midsummer. And one of the really striking things about it is the fact that it spreads so fast across Britain. So it's the 10th anniversary of horse chestnut leaf miner being in this country, which, given the state of most horse chestnut trees, is just remarkable how fast that's happened. So we asked people to take part in two missions. The first mission was the mission pest controllers. What we asked people to do was go out, pick a leaf of the horse chestnut, stick it in a bag, plastic bag, Ziploc bag, wait 2 weeks and then see what came out. So what came out? Was it the alien moths which hatched out of the pupae in these leaf mines? Or was it one of these goodies, the parasitoids, pest controllers, which have laid their eggs inside the caterpillar, eaten the caterpillar from the inside out and then burst out? 11-year-old boys love that. So we worked really hard, working with volunteers, going into schools, doing this sort of project, real hands-on science. And in fact, we were inspired to do this sort of thing because we saw people in a lab at the University of Bristol doing this as part of the research. And we just thought, actually, rather than one paid person checking these thousands of bottles and bags, we could crowdsource this. We could get loads of people to do it. So it was real science, a real scientific protocol. It was hypothesis-led, and we validated the data as well. And so what we found was we took a subsample of the data which the children had entered. We took their samples. We found that, by and large, children could count the mines really effectively. They could count the adult moths really accurately. They struggled a bit more with the parasitoids, and that's partly because the parasitoids are so small. It's also because they're quite rare, so you don't have the familiarity with them. But the key thing about it is that we could actually model this distribution and take that into account in the analyses. So the second mission we asked people to take part in was to look at the level of damage to the trees. All people had to do was simply go out, give their trees a local score. And you can see we got a really good coverage across the country from 2010. So in 2010, it was entirely web-based. The great thing about a website is it's interactive. You can get that feedback. You can see maps of results. It's easy to develop. The disadvantage is that it's not field-based, so people have to remember where they saw things. What would be perfect, we were thinking, was if we could have something that people could just take out into the field, a handheld monitoring bit of kit, could take out into the field, maybe take a photograph, get their location automatically, submit the record there and then. Well, of course, it's obvious now, smartphone apps. And so this was going back about 18 months we developed this, and it was one of the first, actually, of these sort of biological recording apps. And we were able to use that to great effect. The good thing about the apps is that it does allow for more engagement. We got a whole load of downloads of the apps, greater participation. It means that you can potentially access new audiences, those people who wouldn't naturally go into nature but are always playing around with their smartphones. And simply having an app at that time was newsworthy in itself, and it got picked up by a whole load of various different things. Also, really importantly to Darren and me, it led to better science. It led to a greater accuracy of the results. It was much more easy for people to contribute, so we got more data, which was good. And we were able to validate the data because people had their photographs, submitted the photographs of the leaves, and so we could crowdsource the validation. Well, we could check it, but we could also ask people who had previously got involved but weren't out in the field currently to sit in front of their computers and have a go at scoring other people's photos. So we could check that accuracy without it taking up our time. Effectively, we became redundant in the process. A lot of people had a go at doing this. Some people got very, very keen on it. The keenest person scored over 3,000 of these photos, 3,183 to be precise. Why she stopped there, I don't know. Boredom, probably. Anyway, so it's a really effective way of validating the data. And so what did we find? I said it was real science, and we got some real results. So what we found, looking at this graph, the level of leaf damage is greatest where the moth has been longest. That was known anecdotally, but we were able to quantify that it takes 4 years since the moth has arrived in a location for it to reach maximum levels of damage. So that was a novel result. Also, the level of pest control is greatest where the moth has been longest. And for those of you who are statistically aware, you might realise that that's not massively convincing, but that's taking account of all the data validation and the potential error, and that does come out as an important increase, which matches with results which have been found in the continent, but actually, I haven't got time to go into it here, but I think the reason that we've got that increase is different to where the moth has been well established, and we're seeing that increase as well. The whole point is that it was real science which has led to some interesting and important interpretations. So my work on concrete science leads me to make 2 reflections in the context of this discussion. So John Tweddle, who's part of the audience, as part of this review, interviewed loads of potential policy end users for the data, of citizen science data in general. And one of the things that we found from looking at those interviews was that, and this is a generalisation, but it generally seemed to be the case, that that group of potential end users tended to be thinking more about the mass participation aspect of citizen science, partly because its role in terms of engaging large numbers of people. And I would just give the caution that mass participation, when you're thinking about citizen science, is not the only way. What I found with concrete science, there's 5 different aspects of concrete science shown here, is that the retention of participants from one year to the next was lowest where we had the highest number of participants. So it does seem to be that with some of these projects, it's easy in, easy out, and it's maybe not necessarily the best way to build a large community of willing volunteers. I think also the media is a fickle friend. You saw earlier that I sort of name-dropped the fact that we did get mentioned in the national press a couple of times. We almost got mentioned in the national media several more times, and it didn't work out. And if we'd just by chance, a bigger story had come up that day, our story had been dropped, then we would have ended up with much, much less data. So the media can be great in terms of promoting these exciting new ideas, but it's incredibly fickle and it's incredibly chancy. And just some of these thoughts as well, thinking about participation, makes me wonder if there's roughly a citizen science rule of tens, that basically with every step you ask people to go away from their sofa or from their smartphone, you get roughly a 90% drop-off in participation. So if we give people a LeafWatch app, then you get a whole load of participants. You get roughly 1/10 the number if we ask them to go out and then to come back and enter their results in a website. And results which I haven't shown you here, but if you ask people to go out to count something, to come back and enter it on the website, we get roughly 90% drop-off again. And very broadly, I think that's a sort of principle, which again, it's important to be thinking of when designing these mass participation projects. And the second reflection I've got is the importance of data flow. So, going back 18 months to when we developed the LeafWatch app, we used a cloud web storage for our data, which had advantages. It was scalable, it could cope with spikes in demand. We paid as we accessed to put the data in and to get the data out. It was actually surprisingly technical, so I had to rely on somebody else in computer science to get the data out for me to bring it into my own database. And then potentially I could then pass that on to other people, forest research, who were interested in camera area as well. It wasn't really ideal in terms of data flow. The next app, which Dave Kilby and the Nature Locator team have developed, and I had a bit of input into this, was the Plant Tracker app. So we were looking for 14 species of invasive plants, particularly along waterways, with funding from the Environment Agency. And what we did is we used the Indicia database system for this. So the data went into Indicia. The great thing about it is that then a whole load of verifiers could come along. Environment Agency staff, for instance, could come along and say, yes, that is the plant, or no, it isn't the plant that you think it is. It can easily get into places like the NBN Gateway, and then end users can access the data. So for Environment Agency staff who might want to respond very quickly to an outbreak of floating pennywort, for instance, they can access the data incredibly quickly. But if you want to have the larger overview as to how this feeds into the national picture, then it augments the data which is already in the NBN. And so I just want to finish by asking 5 questions about looking to the future and looking wider. So can we be smarter in our use of volunteers? There has been this move within the citizen science agenda away from or to be more inclusive of projects which aren't just about asking people to contribute data, but asking people to get involved more in terms of it being participatory research or it being co-created. People can get involved in the creation of the projects, maybe even the interpretation, the analysis, the design. And so I think, as Keith mentioned, you're blurring the boundaries between the sort of professionals and the volunteers. I wonder if we can also think about moving from surveying to answering hypotheses. I'm really excited about this because it's about getting people involved, not just in data collection, but in the whole process of science. They're seeing the value of their data in terms of the questions that they're trying to answer. I think potentially that can lead to more exciting science as well. It does raise the question as to whether people always need to be engaged. The Met Office have been running this project with the Weather Observations website, so people can buy a weather station which links in straight to their computer. The great thing for the Met Office is that this data from a whole load of locations can augment the data which they collect professionally from weather stations. Often, many people are incredibly involved and interested in the data that their weather station set out in their garden shed is producing. But they don't have to be. They could just set it up, sit back and let all the data just go to the Met Office. If you stick air pollution sensors on Boris bikes in London, people can be citizen sensors cycling around, sampling the air, and know nothing about it. Is that valuable? Is that useful or not? And I think there are a lot of questions, but a lot of potential around this idea of citizen sensor networks. Can we be smarter in reaching new audiences? I think there are probably a limited pool of people who are prepared to go out and do field work. When you're thinking about bats, there are probably an even smaller pool of people who are prepared to go out into the countryside in the middle of the night and spend £400 on a bat detector to gather the data. So given that, why don't we use their time in the very most effective way and save the more arduous process of, in the case of bats, going through the sound files after the event, trying to identify the bat calls. Why not crowdsource that? Why not get people in their lunch hours? Why not get people who, in the dark winter evenings, who don't want to be going out, or maybe who don't want to be going out at all, to get involved in science and do some of these tasks? You can get submersibles taking photos of the sea floor, and then there's another project where people can put these photos, people have put these photos on the web. You can identify what's in there. I spent probably a bit too long in preparation for this talk doing things like measuring scallop shells and all sorts of things. It's real science and people are getting involved, but it doesn't have to be that huge investment. Can we think about the gamification of data collection? Also, can we create new communities? I think iSpot is doing this tremendously in terms of creating these communities of recorders and working really well in terms of drawing people into these virtual networks and these virtual societies. iRecord is a way of gathering lots of incidental data and being able to feed that through something like Indicia to make best use of these incidental records. Hidden away within iRecord are some league tables. It makes it a bit more, biological recording, a bit more competitive. Is that positive? Some people would be hugely motivated by that. Other people would find that hugely off-putting. So I think there's a whole range of questions about where we sit within that balance and what's appropriate for different projects. Can we be smarter in our use of resources? I think the thing is that data are free at the point of collection. Sometimes people even pay to take part. So the Garden Birdwatch, you pay an annual subscription fee. The Mammal Society have their tongue twister of the mini mammal monitoring. As part of that, you can buy your own DNA sampling kit to collect droppings from small mammals, send them off to be identified. So people are paying to get mouse poo identified. Well, you don't know it's mouse, it might be vole, actually. That's why you need it identified. The thing, though, is that citizen science is costly. Again, Keith alluded to that. You've got an infrastructure to make the best use of the data. It does require investment. It does require support. And if you want to innovate, then that's even more costly. Very roughly, for each of the UK headline indicators which rely on volunteer-collected data, each one of them cost in the region of about £100,000 per year. And this came out of the case studies as part of that UK EOF report. So it's free at the point of collection. It's hugely cost efficient, but it's definitely not free. In terms of thinking about our use of resources, can we share experience? Can we make best use of those potentially relatively limited pool of volunteers, as well as reaching out to new audiences, as I asked earlier? We need to ensure that all the data is used, that the data is shared, that it's reused. We need to ensure that the same job is not done twice. And I think there is the risk with this exciting environment of the development of things like smartphone apps. It's absolutely tremendous to see the creativity, to see all these diverse opportunities which are coming out. The risk is that for some of those, the data may just sit on people's local hard drives and go nowhere. And there is the risk that there's this balance between diversity is really good and diversity can potentially be a problem because it causes this confusion. Often people want to do the right thing. They want to report and they want their information to be useful. And I've got 6 ways of reporting it, and some of which may not be good and some of which the data may be used. Where do people go? Is there the risk of market saturation as well? Maybe not. Maybe it's just reaching out to lots of new audiences. Does citizen science need overseeing? Biological citizen science need overseeing? There's a question. Can we be smarter in our use of technology? There's a whole range of really exciting things. So why not buy a plug-in Geiger counter for your iPhone? And if you're in Japan, you can... This is genuine data, or genuine science which is going on, and you can see real-time maps as to the radiation levels in Japan, which of course was of huge concern just recently. Maybe you want to buy your own conservation drone and do what they've been doing in Indonesia and use these things to fly automatically over the forests and identify orangutan nests. If you work near an RAF base like I do, that's probably not wise. So maybe instead you would like to go down this route and follow the public laboratories approach of taking cheap digital cameras, modifying them to make them into infrared cameras, sticking them on kites, and you make your very own remote sensing vegetation sensor. Really exciting stuff. You're getting all these really cheap, small and cheap yet powerful microprocessors which are going out, and you can get a whole load of plug-in sensors for these sorts of things. We're going to be talking about this a bit more on a workshop on technology and citizen science at the Intercol Conference coming up next August, and you can talk to me if you want to find out more about that. Can we make more of the data that's out there? So there's a whole load of data. People put all sorts of things on Facebook and Twitter. In California, they're looking for monitoring sudden oak death and trying to report or see where people have tweeted or people have tagged photos in Facebook and in Flickr with mentions of sudden oak death or oaks dying. That may help to give an early indication as to the spread of this disease. And of course, technology can be used more and more powerfully for data visualization, for feedback to participants. And the final question is, can we be smarter in our use of the data? In the old days, there was this approach where citizen science projects were largely separate. Maybe there might have been a bit of sharing between them. But actually, the vision of the future is that all these projects feed into database services. Maybe there might be a biodiversity service, a meteorological one, a geological one, a whole load of different things. And if these services can talk to each other as well, people in the States have said, this is the future. I think to a fair degree, that's already happening with some of the tools like Indicia, which allow this sort of approach. And so just finally, what can you do? Just to remind you, the Citizen Science Guide launched today. And to do a second launch, I've never done 2 launches in one day, at CEH, as part of the Biological Record Centre, in conjunction with BTO, we're running a project which is looking at monitoring change. And what we want to do is try and understand the priorities for taking biological monitoring forward in terms of its value for monitoring change. So it'd be great if you could take part in this survey. The details are at the Biological Record Centre website. It should take 5 to 10 minutes, so it's not too arduous. But it would be really valuable to get your perspective and tell lots of other people. That would be great. So I think citizen science, it's about data, it's about collecting excellent quality data and doing lots with the data. It's about people as well. It's about engaging with people. And I think the other thing is, as Linda said, citizen science is fun. So thank you very much.
That was a very interesting talk. I can tell you that the Recorder League in iRecord works for me. I just imagine someone on a Boris bike with their mouth open. They would actually be a bug catcher, wouldn't they? Are there any questions for Michael?
Hi, everything you discussed today is very much a top-down approach. You say about hypothesis-driven use by volunteers. But from a policy point of view, if you had a citizen science-driven approach, which had a citizen science-driven approach from bottom up, how seriously do you think that governmental departments would take a group of local people with the information you described that's not gone via academics? I'm not going to hold you to it, just surmising.
I think, to an extent, that has already happened within the biological recording community, actually, that there are various classifications for citizen science projects about being contributory and, or co-created. And actually, many of the biological recording schemes don't really fit in there because you haven't got professional scientists who are leading it. So I think already that is happening, and that does show, and that data obviously is valuable in terms of policy. I think there's also another aspect which maybe slightly sidesteps the question. In the US, there are lots of very local projects, all looking at water quality. So they might be for a particular creek or for a particular watershed. And states have got a responsibility to report on water quality. Local people and local communities have got a stake in how good their river is. And what actually has been drawn up there is, because obviously the data could lead to potentially polluters being sued, so therefore it's important that it's excellent quality data. And so there have been protocols which have been established and signed off. Everyone taking part in that water quality monitoring will have a degree of training up to a certain standard so that they can take part. And then it means that the data collected are can be used in legal proceedings. And so that has been one approach. But then what's interesting about that is that local communities have taken sort of that core and they've adapted it and they've changed it and they've promoted it, and it's done in a whole diversity of different ways. So that may be one other potential model which I didn't really discuss here.
There was another question there.
Hi there, Andrea Turner from the UK EOF. We're the commissioning organisation that commissioned this work. Just wanted to flag up, we have our leaflet in your packs so you can find out all about the sort of things we're doing. And also to say that not only is this coming from the Biological Record Centre, as Michael and his colleague Helen Roy, and also the Natural History Museum, but if you look on the back, there's a list of UK EOF partners, which includes CCW, Natural England, Met Office, and all these organisations have contributed to our guide, which has been launched today. So very serious backing from a range of organisations, and take a look and pass it on.
Thank you. Are there any more questions? For this one right over there, Trevor.
Run.
This is for the YouTube audience.
Thank you very much. In the interest of making the most of everybody's efforts and avoiding some of the duplication that you can get with biological recording a lot, do you think there's any merit in the idea of a kind of quality flag sort of approach to some of these apps, so that you can look at it and you say, oh, actually, that has an NBN leaf on it. If I do that, it will link in with other schemes. It won't just disappear. They have looked at it. They think it's okay, and it's probably, going to be of some use and probably going to connect up with other things. My worry about these apps is that they're not really connecting up in a lot of cases. And so we're getting, for example, in Gloucestershire, I work at the Gloucestershire Centre for Environmental Records. Like a lot of local record centres, we're aware that quite a bit of public effort is going into recording things which we will never get the records for. And if they ask us about it, they'll say, oh, we did this or we did that, and we recorded it and it ended up on a map on a website. Why don't we know about it? Well, actually, we can't use that, really. And yet every week we're doing things like checking planning applications and providing information for strategy. And none of this is perfectly good data. I don't think there's normally a problem with it, but none of it can be used. I think, as someone that has used the apps myself and who is also a recorder, it would be nice to more easily be able to tell which are worth it and which are just kind of a rather ephemeral bit of fun, which kind of looks nice for the time being.
Well, you say, yes, you say an ephemeral bit of fun. There is value in engagement in its own right, but it can sometimes be almost a bit disingenuous if it appears that somebody can participate because they're doing real science and the data don't go anywhere and there is no value to it. So yeah, I was having a chat with somebody just the other day about the sort of idea of maybe there ought to be something like an NBN logo on these apps. I guess there could be discussion as to who would be the authorising body to provide that little logo. I think there is merit for that. I think also, though, there is this excitement. It's like there's this burst of creativity, this burst of activity. There's all sorts of things going on all over the place. I think there will be a period in a few years' time, certainly in terms of the smartphone app environment, if we haven't moved on from smartphones, that it will have settled down a bit. And I'm just, in a sense, I'm really torn because I love the diversity. I love this creativity that this is fostering, the innovation. It's exciting. But equally, I recognise that we don't want to be misleading. And if we are getting data, let's use it. And I think porting the data through things like the NBN is really ought to be the absolute minimum that people are doing when collecting these records.
I wonder if I could just answer that question as well. You've touched a raw nerve. The matter was discussed at our board meeting on Tuesday, and the recommendation is that we will promote a new brand, NBN Toolbox, something of that nature. I can't be quite specific about it, but there will be a set of standards and criteria that if an app or indeed any other development meets those conditions, then it could be badged as contributing to the NBN. And the significant ones, and this isn't an exhaustive list, but the significant criteria would be whether those apps were using the standard nomenclature for the species, which is derived from the species dictionary developed by the Natural History Museum, whether there was some form of verification stage, and it might be the sort of photographs and things that you were talking about, but it would have to be appropriate for what was being recorded, because we all know that in some cases photographs just aren't enough to confirm an identification. So it would have to be an appropriate verification stage. And that, most importantly, that there was a route map to put the data onto the NBN gateway. So those would be the three fundamental things. There are some other bells and whistles that go on top of that, but we will be promoting those standards in the very near future. Thank you very much, Michael. That was a very engaging and interesting talk. And perhaps at the end of the morning session, there might be an opportunity to raise some of the strategic issues which come from Michael's talk and from Linda's talk. Trevor, can you sort this laptop out while I introduce Nick Isaac, who's got an act also from CEH, with the most intriguing title to a talk, Interpreting Biodiversity under Diverse Syndromes of Recording Behaviour. I never thought recording was a syndrome.
I'm not sure about that.
Well, I'm afraid I agreed to give this talk long before I'd given any substantial thought to what was going to be in it. So you'll be pleased to know that I've got a slightly more digestible title. Thanks, Trevor. So, interpreting biodiversity under diverse syndromes of recording behaviour, or extracting trends from biological recording data, which I hope will be a little bit more digestible. Okay, so I thought I'd start by going back to the question of the day, which is biological recording fit for purpose? And to me, that raises a number of other questions. And the first of those questions is, what is the purpose? What are we trying to do with the data? What data are there? What are the problems with those data? And what tools do we have at our disposal that might provide a solution? So I'm going to talk a lot about the latter two or three during the body of the talk. But first of all, what purposes are there? Well, I guess the bread and butter of recording over many years has been describing species distributions, understanding where things are. And that's essential from a sort of natural history perspective, but it also underpins some of the more applied uses of the data, such as in planning. Detecting and attributing change, by which I mean trends, and really that's going to be the focus of what I'm talking today. And for me, I guess the third type of real purpose was touched on earlier, is identifying novelties, so new arrivals. And these include some fairly benign and welcome additions to our biodiversity, like the small red-eyed damselfly, and some less welcome arrivals like the Chinese mitten crab and Japanese knotweed. So biological recording has a number of really important uses, of which these are just a select group. I'm going to be talking mostly about the second one today, trends in species distributions, attributing change. What about the data? What does the data look like? Well, here are the NBN data for the pygmy shrew, Sorex minutus. And I look at this data and two things are immediately striking to me. The first is that this species is very widespread. It occurs in, throughout England and Wales and Scotland and Northern Ireland. The second thing is that there's some very large holes in this distribution. It's very patchy. It's not found at all in South Wales, or barely at all. And does that reflect the fact that it's genuinely not there, or does it reflect the fact that no records have been submitted? Nobody's gone to look for it, for example. And this unknown, the degree to which we don't know where what the blanks mean, is the great problem to me of biological recording data. This asymmetry of information. We know that a record is a reliable indicator that a species was present, but the absence of a record doesn't tell us that it wasn't there. So how do we interpret the gaps? The other thing, I guess, to say about these data is that they come from a variety of different sources, from a range of different types of people, with different purposes, different sampling intensities. So interpreting the data in the whole is not straightforward. So I guess that's one reason that published atlases have been so important historically. And as we've already heard, we're celebrating this year the 50th anniversary of the original atlas of the British flora. So they're our primary tool, at least historically. They provide us with an authoritative summary of the status of our flora and our fauna, and they give us a snapshot of species distributions. And we've now got atlases for a wide variety of taxa, including some of the less charismatic of our invertebrate groups. So we know quite a lot. We know even more when we have repeat atlases. We've already heard from Michael that the new atlas, the second atlas of the British flora, was published 10 years ago. So we can measure change over a several decade period. And this shows, okay, so repeat atlases allow us to assess change over time. And here's an example of one species, the prickly lettuce, and it shows that very clearly that its distribution before 1970 was restricted to the home counties, and it's spread quite substantially since over the past 3 decades. So we have an indicator of change. And that kind of comparison between atlases is possible for these 3 groups, birds, butterflies, and vascular plants, for which we have repeat atlases. And that's been quite powerful in shaping our understanding of trends in native biodiversity. And this paper was published in 2004 by Jeremy Thomas, and they counted the distribution, they counted the squares of the distributions of all of the plants and all of the birds and all of the butterflies in both of the atlases. And this gave a measure of the amount of change in the distribution of each species. And then they were able to compare not just among species, but among the major groups. This tells us that the greatest losses have occurred amongst butterflies and then amongst birds. And I think this paper's been very influential in the way that we think about biological recording data and what it can do to inform trends. But a lot has changed since 2004. So I'd like to think about what's happened in the past 8 years. And I feel there's an increasing realization that atlases, even repeat atlases, give us a fairly static view of biodiversity. They tell us over a period of 10 or 15 or 20 years whether a species was found in a particular 10-kilometer grid cell. Also, the fact that the data are very unstructured in space and time makes simply counting squares rather unreliable, and more on that in a moment. Increasingly, though, both researchers and policymakers are demanding quantitative information. How fast are species changing in their distributions? We also, increasingly, have methods that are able to provide those quantitative estimates, to estimate the trends in species distributions. And that's going to be the subject of most of my talk today. One such method we developed for this study, published earlier this year on ladybirds. And we looked at trends in the distribution of 8 native ladybird species, both in this country and in Belgium. And so we estimated a trend for the species, and we estimated how that trend was influenced by the arrival of this species, the harlequin ladybird, which came to this country in 2004 and to Belgium in 2000. And these graphs show how the distribution of each species has been affected in each country. The dotted line shows grid cells that were colonized by the harlequin, and the solid line shows species that have so far avoided being colonized. And you can see that for most species, they show a very substantial negative impact of harlequin ladybird arrival. So this takes us forward because we now have quantitative estimates of change, but it also takes us away from simply describing change to attributing causes of change. I think in the future, though, we want to go even further away from simply attributing the causes of change to being able to make some kind of statement about the general state of biodiversity. This is the Living Planet Index, which is updated every year, and it's based on population abundance estimates. To date, there aren't any indicators such as this based solely on species distributions. So my talk today is going to be in 3 parts. The first is about what biological data look like, problems with the data that make estimating trends difficult, and some possible solutions. I'm then going to describe to you a study that I've been working on to compare different methods using simulated scenarios of recorder behavior. And finally, I'm going to ask what species are in fact declining using some of these methods and using examples of the dragonfly data. And I'm going to have a sort of first stab at a biodiversity indicator. But this is, I guess, 2 caveats. Firstly, this is all very new. Most of this work was done yesterday. And so it's a work in progress. But also, it's important to say that this is based really only on the data that we have in front of us right now. So I guess the most striking pattern is that recording intensity varies dramatically among major taxa. I haven't put birds here or vascular plants, but you can see that the other group with 2 atlases, the butterflies, are well out ahead, with something like 2,000 records being submitted per year per species. And the dragonflies are the next best group with about 300 to 400 records per species. And the median among these other groups is around about 20 records per species. So an order of magnitude less detail. Surprisingly, quite consistent, though, that the number of groups that fall within that range of about 10 to 50 records per species per year is quite great. And there's a sort of a deeper question here. We've gone for the easy taxa first. We've looked at the birds, the butterflies, and the vascular plants. We can look at the dragonflies. How far down this scale of intensity can we go and still estimate trends in species distributions? So how do we estimate trends? Well, this is one way. We simply plot the number of records for a given species over time. And this would be quite a reasonable thing to do if the data was sampled randomly in space and in time, like an experiment. But we all know, of course, that that's unfortunately not the case. And the most prevalent pattern we see when we look over time is that recording intensity has increased dramatically for most groups. This is a log scale, and so a straight line, which is approximately what you see for butterflies, corresponds to exponential growth in the number of records being submitted per year. Most groups here actually show a substantial increase in the 70s and 80s, followed by a period of stasis. And then we get a little bit of dropping off at the end because we haven't yet received all of the data that's been collected. We haven't received all of the records. But within this, there are some quite odd patterns. I don't know if you can pick out in dark blue the moths, which seem to suffer very much in the late 80s and early 90s and had only about 20% of the records being submitted as in the 70s and in the last decade. So recording activity varies dramatically over time with a general pattern for an increase over time. And this means we can't simply plot the number of records to estimate whether the species has declined or not. This method is Telfer's change index, has been used quite widely in the literature, and it's based on comparing the number of squares in which a species was recorded in two different time periods, and when those time periods differ either in recording intensity and or in geographic coverage. And for this species, whose name I forgot to write down, is a species who appears to have declined somewhat. I don't know if you can see in red there. Its distribution is smaller than you would expect it to be. And this is quite a reasonable method, but it doesn't give us a quantitative estimate of the change in its distribution. Another method that does is I call the visit rate model, developed by Stuart Ball. And this says, for any given year, how many visits occurred for a given taxon, and how many of those visits returned a record for the species of interest. And then by plotting this proportion over time, we can estimate a trend that is robust to changes in recorder effort over time. So Ball's visit rate model is one that I'll be using in my comparisons. Another problem, though, is that most species lists are what I call incomplete. And here I've plotted the proportion of visits that return lists of 1, 2, and 3 species. And they're ordered, the taxonomic groups are ordered from the isopods over at the left-hand side, where 75% of all visits return single species records, over to the bryophytes, top of the class mark, which are down at about 40%. 40%, though, still seems to me like quite a large proportion of visits that only return a single species record. And we can think of many, many reasons why we might record only a single species. Perhaps the weather was really bad, and or sampling only was occurred over a very short period of time. But much more likely, we were only looking for a subset of the total species that were available. For example, we might only have seen the commonest species, and this is a particular problem with new recorders. The other thing that new recorders tend to do is they only record rare and interesting species. and they don't tell you. If I go outside and I see a golden eagle, I would probably record it. But I might not tell you that there was a robin hiding in the bushes. So interpreting these single species and these other short lists of 2 and 3 species, is hard. And it's made harder by the fact that this list length, or the number of visits, number of species recorded on a typical visit, changes over time. I've just picked out here the groups that show the most interesting patterns. Again, bryophytes, top of the class, nice and steady over time. But some other groups have tended to record steadily shorter lists. Others have tended to record steadily longer lists. And I think, again, the moths and the beetles show some very peculiar patterns, the ants as well. So we might expect that simply looking at the proportion of visits is going to be problematic for taxa that show this kind of pattern. That's because if lists are getting shorter and shorter over time, it's harder to get on any one species list if visits are returning shorter and shorter lists. So it might bias our estimate of what the trend is. This mixed model is the model that we use for the ladybirds, and it's based on the idea of throwing out a vast quantity of the data, particularly those lists with single species, and estimating a separate trend, if you like, for each site. Each line here is supposed to be a different site or a different grid cell, and looking for the average trend across grid cells or sites. So that's one way of dealing with incomplete recording. We've already heard that 99% of lichen data comes from just a few recorders. Well, the same is true for beetles. 50% of all of the beetle records come from just 47 recorders out of 10,000 recorders. About 9,000 of those recorded just a single record. But this domination of recording by just a handful of people is a really general phenomenon. These are the numbers here on the right for other groups for the number of recorders submitting half the total records. Just 18 people for bryophytes, 11 for myriapods, 102 for moths, 39 for Orthoptera. So we're relying on just a small group of people. This is especially a problem because recorders are very highly structured in space. These are the top 4 recorders of Orthoptera data, and they show really characteristic spatial patterns. They tend to record near to where they live. This is a heat map, so the red squares indicate a single visit, and the brightest yellow, or the nearest to white, are the grid cells in which they've recorded very large numbers, or they have made very many visits. And you can see recorder number 4 here never left Essex. You can see that recorder number 2 has recorded very, very intensively in Norfolk and occasionally went on holiday elsewhere. And really, number 1 and 3 are unusual in that they have both multiple hotspots and also have been recorded more widely in the country. These 4 recorders contribute about 14% of all of the visits for Orthoptera data. And there's almost no information here from the Midlands, and no information at all from Dorset, one of the best counties for Orthoptera. So this is a problem. This is especially a problem if the factors that are driving changes in species distribution are spatially patterned. For example, if species are responding to climate change. So one other method that deals with this is a method that Mark Hill developed, which is either called Frescalo or Frescalo, depending on your preference. Now, Frescalo estimates for each grid cell the degree of recording intensity, and it provides a way of getting around this spatial pattern in the way that records are distributed. And this is an example from the Dragonfly data, and it's the fitted output from Frescalo. And it shows us in red the parts of the country that are deemed to be under-recorded, and the white areas are those that have had the most intensive recording. And what this allows us to do is to take, on the left, the observe numbers of species in each grid cell and derive an expected number of species or a rescaled number of species. The number of species that should be there if the grid cell had been intensively sampled. And we can take this method further and ask how then, given recording intensity, how the species distribution has changed over time. This is an example from 3 mosses that all appear to show an increase. So we've now got several methods for dealing with different aspects of this recording problem. I'm just briefly going to mention occupancy models, which estimate annual probabilities or indeed a linear trend in occupancy over time. And this may be a panacea because it's a very powerful technique and it controls for all sorts of different aspects of recorder behavior. It does this by separating out mathematically the probability that a species was present from the probability that it was detected. The problem, though, is that it's incredibly data hungry. It's also very computationally intensive. So it remains to be seen quite how far this kind of method will be useful. So how am I doing for time? 10 minutes. Okay. So I'm now going to compare some of these methods using realistic, or I hope vaguely realistic scenarios of recorder behavior, and ask which methods are useful. So we've got these raw data, these biological records that are unstructured in space and time, or at least oddly structured. And we want to estimate some trends, but we know there's these issues with recorder behavior and intensity varying. So I'm going to use some computer simulations that generate raw data that looks like real data based on certain types of recording activity, estimate trends from the simulations in order to interpret how to estimate trends with the real data. Briefly, I want to compare the performance of the methods, discard the methods that don't work, and derive some kind of rule of thumb. If your data look like this, use this method. If your data look like that, use the other method. Some details which I won't go into. I had a lot of data. I generated some data. I generated some recorders going to visit these sites to return biological records for multiple species. And I ran this over 10 years to estimate trends. There are no real trends. There are no changes in the distributions. I should say this is Arco van Strien of Statistics Netherlands, who's my collaborator on this work. I imposed a variety of different patterns of recording to get at these different elements of the recorder problem. The first is a sort of idealized scenario. Recording is random in space and time, but there are no biases. Each site has an equal probability of being visited every year. The second scenario is simply an increase in the rate of recording. In the third one, we've got incomplete recording, but every year, a fixed proportion of the visits produce short lists. And finally, incomplete recording that gets more extreme over time. And the thing that I'm estimating here is what I call the type 1 error rate. You can think of this as how often do we get a significant correlation, a significant trend, when in fact there isn't a trend. And we have to do this over a large number of replicates because some replicates return significant relationships and some don't. Because we're using a p-value of 5%, we expect that about 5% of simulated data sets will generate a significant result, somewhere in the middle there. And you can see that some methods are slightly below that and some are slightly above. For this idealized scenario, most of the methods, though, come pretty close to 5%. A couple of them are a little on the conservative side, but that's okay. The change index, the simplest method, it's a qualitative method, tends to be always conservative, but never wrong. Number of records, well, as expected, it falls over under several different scenarios. Not surprising, really. The visit rate model falls over when we've got this incomplete recording that increases over time. Again, because it's harder to get onto a shorter list. I should say this mixed model has several different definitions of what we consider good sampling or well sampled. And you can see that as we increase that threshold from 2 to 3 to 4 species, the method gets better. And finally, for Scalo, surprisingly to me, at least, it falls over when recording intensity increases over time. I thought this was a problem with my simulations, but Mark assures me it's a known problem. So this is very new, but it may be that this method is not such a good one when recording intensity increases dramatically. But that's very preliminary. Across all methods, there's a variety of patterns. Probably it's the mixed method. The mixed model is the one that is least often wrong. I then repeated all of this in which the focal species was declining at a rate of 30% over the 10-year period. That is the rate of decline specified by IUCN to qualify as vulnerable. And you can see that pretty much all the methods detected that that trend was significant about 60% of the time. And that power decreases under these different scenarios of recording behavior. So the simulations give us a way of comparing these methods under different recording scenarios. And I plan to run this under different types, different parameter values to make the data sets that come out look much more like different types of schemes data. This mixed model appears, so far at least, to perform best. And we've got this power of about 60% to detect that negative trend. So I'm going to end up by talking about using these methods, using the data from the British Dragonfly Society. So I've used two methods here. I've used Frescalo and I've used the mixed model. And plotted here are 32 of our native dragonfly species and their trends over the period 1970 to 2011. And although there's a lot of scatter, there's broad agreement. Most species are either increasing under both methods or decreasing under both methods. Note that we wouldn't expect a one-to-one relationship here because they measure trends on different spatial and temporal scales. So they're broadly in agreement. 14 of the 32 species show significant increases under both methods. That's reassuring. It's also a very high proportion of the dragonfly fauna appears to be increasing. 2 out of the 32 show significant declines under both methods. So what are they? Well, these are the 3 winners. At the top, it's no surprise that our biggest winner is a species that wasn't even here until 1999. So, of course, that species has grown. The small red-eyed damselfly has expanded the fastest. The other 2 big winners are the scarce chaser and the emperor dragonfly. The losers, well, these are the only 2 that are significant under both methods, that are the variable damselfly and the blue-tailed damselfly. There's a couple of other odd ones here. The common blue damselfly appears to have a very negative trend under one method, but absolutely flat under another. So that may be a recording issue. And so I thought I'd end with an attempt to synthesize these trends into a biodiversity indicator. Effectively, what I did is, instead of estimating a single trend for each species, I estimated an annual probability of occurrence in the average grid cell. And I simply averaged those across species to get an index. And that's what it looks like. We can say that the dragonfly fauna on average, according to this model, has increased and now sits around about twice as high as it was 10 years ago, 40 years ago. This is very new. I'm not sure how robust it is at this stage, so don't quote me on it. But I think it demonstrates the sorts of things that we can do with these data. So I thought I'd end by looking forward and thinking about what we can do, or looking, now we are in the 21st century, or we've been in the 21st century for a while now. But we do have the tools, I think. We do have the tools to model biodiversity change using these kinds of unstructured data. We're not quite sure which tools are best, but we have a good selection to work from. We can't really do this unless people carry on submitting records to the dataset. I can't emphasize that strongly enough. We've heard it already this morning. And that relies both on volunteers going out to collect the data, but also on those data being submitted to the database. Thirdly, we could be much smarter about the way that we collect data. I mentioned right at the start, one of the big problems is this asymmetry of information. If we could have more information about what an absence means, that would be really helpful. So one way, for example, is to record at the point of which data are entered, whether, for example, a search was exhaustive or whether it was merely just the 2 or 3 species that were of interest. I think we could have a discussion about how to achieve that. So knowledge about the degree of sampling. And finally, I think I'm really excited. I think we're only really just beginning to see the potential of these kinds of data, and we can do all sorts of new things that we really are only just beginning to think about. I've talked a little bit about indicators. I'm working with the Bees and Wasps and Ants group on a red listing project using this approach. We can also start to think about agri-environment schemes and ecosystem services that, based on the services that species provide and the records for those species. So I'd just like to thank a few people. Tom August has provided a lot of the figures. I've benefited greatly from my collaborators and colleagues at CEH. Really, the main thanks go to the people who collected the data, though, in all of the schemes and societies, without which none of this would be possible, and the people who paid for it. Thank you.
For a minute there, I was a bit worried that we were going to have a trend analysis whether we were in the 21st century. We've got a few minutes for questions. Any questions for Nick? No, I think you stunned them all, Nick.
Oh.
Thank you. Right, now we've got a quick word from our sponsors now. Nigel Jackson is going to talk about the mineral products industry and how it's uniquely placed to benefit nature.
Thank you very much. Is it on? And the presentation is there, just in case you want. Is this? Do I need to do this? Okay, well, good afternoon, everyone. Thank you very much for having me. On behalf of the MPA, I'm delighted to be able to sponsor today's event. There's quite a lot that I could cover. What I'll try and do is get some of the obvious things out of the way. I mean, the good news is it's Friday. It's better news that it's nearly lunchtime. The sun is shining. I've got less time than everybody else. And I ration myself to one external PowerPoint slide a month. Now, it's November. I'm under budget, so I'm going to use 2 slides today, but I'm going to use one of them twice. But in terms of who are the MPA, I'll refer you to this document in your pack and a little Maoist message card. The Mineral Products Association represents all of the aggregate, concrete, asphalt, industrial lime, agricultural lime, mortar, silica sand industries in this country. And not many people know that that is the largest material flow in our economy. It's about 1 million tonnes a day, 250 million tonnes a year, and is critical to our built environment. I'll come on to what we do with the natural environment. It's actually more significant in tonnage terms than oil and gas and coal put together, but probably most people wouldn't know that either. So I think what I say to you is that we are trying to raise awareness of that understanding through a campaign we have called Make the Link. And as I say, referring to the Maoist card, that there are some key indicators there which will help you make that link. But our Make the Link campaign is not just about making the link to the economic contribution, it's to the wider contribution we make to the UK. And one of the things I'm here today to do is to try and help you make the link to what we can do and can do with regard to biodiversity. Bad news for you is that I'm a geologist. The good news is that I did do a subsidiary when I was at university some 40 years ago. It was called Organisms and the Environment then. I don't think we'd really quite got the new language. The bad news is I wasn't very good at it, but the good news is I was good enough. And being a geologist and doing a little bit of work on the environment was quite a good combination, actually. And I think I've worked out in having to talk to you today where my passion for this subject came from. I was obviously very pleased to be stuck on a beach profile somewhere in Pembrokeshire, doing quadrats and counting species and all the rest of it. And therefore I got a grasp of local habitat and local speciation. In my mainstream studies, I was very struck by the work of a paleogeographer and a paleobiologist called James Valentine, who was very, very convincing about some of his theories about the assemblage of the continents and how they move and how that interacts with the climate and how that bears down on the diversity of speciation. And had I had more academe in me, I would have very much liked to have explored that subject in more depth. But it has stuck with me throughout. And therefore, at one end of the spectrum, I see the long-term geological aspect here. And on the other hand, I can see what happens at the small scale on the short term. And really, it's about the geometry of the habitat and how that can bear down, and the changing geometry and how that can influence speciation, which sticks with me. So I'm trying to, in some pathetic way, ingratiate myself to you by convincing you that I'm actually deeply earnest and academic about this. I may or may not have succeeded, but trust me, I do care about this, as does the industry. This is not a sort of clip-on PR thing for us. It is up there with other key issues for us. Health and safety is our number one collective concern, whether that's for our employees and contractors or those we interact with. Carbon reduction is very, very serious for us. The whole sustainability agenda is very serious for us, whether it's natural environment or built environment. And we're doing an awful lot of work on how can you reduce CO2 arising from the energy required to maintain cool and warm buildings. We get involved with many other issues too, the interaction with the public, whether they're on a cycle, because we probably have the majority of the HGVs on our roads, and that's a very hot issue here in London. So there are an enormous range of issues that bear down on our particular sector. And I think I've got one for every letter of the alphabet, and it's just fortunate that B is the second one, so biodiversity gets there however you odds it. It's very tough out there for our members, and therefore you'd think that they would squeeze out whatever they really want to do, because some things get unloaded when we're in recession. I'm pleased to say that even though it is tough, and we are 30% down on where we were in 2007 in terms of the GDP of the sector, there is no weakening in the passion of our members for this subject. And we do have a biodiversity and nature conservation group who meet regularly to talk about these issues, where the companies have their own experts and we try to upload that expertise where they feel able and then share that amongst our membership. And we're very grateful for the work that they do. There's probably about a 40 or 50-year track record of high-quality restoration of quarries. It's a very rich and significant legacy. But I think what we, through the work of the bank group and our members, we realise there's a lot more that could be done. I think we've identified that biodiversity could be a very unique differentiator for our sector compared to many others. And in fact, it could become how we define ourselves. So I've only got one slide for you, one that I will repeat. And if the only thing you take away today is the message from this slide, it is basically that we consider ourselves to be uniquely placed because we have this very, very significant and dramatic interaction with the environment. Now, that is a threat many days of the year to those who may happen to live near a quarry or some other form of mineral excavation. But equally, when it comes to biodiversity, I think it is a genuine opportunity. We've always regarded ourselves as borrowing the land and improving it. And I have been a practitioner myself. I have got a track record I can call on. I know where I've improved agricultural land, even from grade 2 to grade 1. I've been involved with many conservation schemes where we've managed to put a little bit more back than we took away. But there is this impact during the operation of a quarry which can give rise to significant difficulties. But I think we're getting better at managing that. We understand land. We harvest many crops. We don't just take the mineral. We use the air. We refill the air created by the removal of the mineral. And we often return it to agriculture or some other beneficial after use. And very often sites can be developed in all sorts of imaginative ways. And I think we're getting better at explaining that. I think we're very expert practitioners. And if I had to find a collective description for you, it would probably be environmentalists. I think we regard ourselves as being equally environmental. We just happen to be in it, interacting with it and moving large parts of it a large part of the time. And just to give you some idea of some of the things that we've achieved, it's interesting when the government came in, DEFRA set its ambitions for delivery on the ground, and it wanted to plant 1 million new trees and have 12 new improvement areas. We planted over 1 million trees in the last 5 years that we measured that, and that was in addition to 36 miles of hedgerows and about 13 miles of dry stone wall. So there's a lot of practical stuff going on out there, and it all has, I think, a relevance. Don't take my word for it. I'd invite you to Google some of the stuff that's been said, but Chris Smith, chairman of the EA, he has publicly said that we're ahead of the rest of the world. Paul Christensen has actually said that he considers our sector as being capable of creating net gain, and it does, and that's not recognised enough. So I think there is a bit of a shift in perception from us being just a threat to an opportunity, and certainly a potential opportunity, and maybe from unwanted to recognising that we are essential, not just to the economy, but we are becoming increasingly sustainable and can make a profound contribution to biodiversity. So I would say it, but I do believe that we are world-class practitioners. I think we've got things other countries around the world can learn from us, and I think we will become recognised as being certainly a key contributor to UK biodiversity gain. Some of the other metrics about what our members have done, they've created 2 national nature reserves, 22 local nature reserves, 15 study centres, 13 nature trails, and they control and manage collectively about 115 square miles of land. Now that's equivalent to a small national park. It's a kind of Norfolk Broads type of quantum. And we've been pleased that other organisations have helped identify how we can add value, how we can build on that legacy. And work we've done with the RSPB through the Nature After Minerals project has really helped, and I think it's inspired us to go further, to achieve 9 of the 11 BAT targets on habitat creation is a real prize worth having, and we're on that case. So I do believe that we're uniquely placed. I think we can protect, nurture common and protected species. Our asset base is massive, and the opportunity is not just onshore, it's offshore. I had a little chat with our marine operators yesterday, and I entered the room as they were talking about the red-throated diver, and my immediate thought was that somebody had gone overboard and had a nasty incident which might have caused them to asphyxiate. So I apologise for being a bit ignorant on that one. But the interesting thing was, in the search for renewable energy, and we're heavily involved with trying to make the most of the wind energy opportunity in the hope that they will use and consume vast quantities of concrete. But above and beyond that, it was interesting that the red-throated diver had become brutalised by the London Array and other developments in the Thames estuary through wind energy, and the birds had decided that they were going to go somewhere else. So they decided to sit in areas which are highly trafficked, mainly by other ships. We're about 5% of the flow, but it does create a conflict with the dredging of aggregates, which are pretty key to London. In fact, 50% of demand in London is dependent on what comes from the sea nearby. So it was quite interesting. We're solving one environmental problem over here, trying to get carbon down. That hits the birds. The birds don't like it. They go over there. That hits on the aggregates. And our members were saying, this has only happened in the last week. What are we going to do? So now we're now talking about, I think somebody mentioned earlier, drones to fly the area to see where the birds are and where they're moving. It never ceases to surprise me what comes up in a week in our industry. But the opportunity is huge. And we've tried to respond to this, and we started with a series of biodiversity exchanges involving many people in this room. And then we developed our strategy, which should be in your packs, which was launched in the House of Commons with Minister Richard Benyon in the room. That was last year. Now, that's all very well and good. For me, that's the easy bit. The easy bit is to come up with the 6-point plan. The issue is, well, how are we getting on? And I thought I'd just update you on a few of those developments. On the knowledge aspect, we are discovering what many of you do, that getting data, defining what the data is and what you do with it is a challenge, but we're interacting with our members, and we're trying to get to grips with that. We're looking particularly at habitat creation. What have they created over what period of time, and what are they planning to do in terms of restoration? And what will be the contribution, not just locally, but in terms of landscape scale post-Lawton? Because I think we particularly have some leverage there. So that process of inward looking and data gathering is going on, and it's challenging us, but I think in doing it, we're learning. On sharing best practice and partnerships, we're working with many NGOs, particularly wildlife trusts and other groups, and finding that it's good for them, I think it's fair to say, and it's very good for us. And I'm pleased to announce today that we've signed 2 new memoranda of understandings. One is with pond conservation, so that we will support the Million Ponds project, because that's something which is eminently practical as far as what we do on a day-to-day basis. And the second one is with the Bumblebee Conservation Trust. We recognise that that's a key species challenge for us all. Our aim isn't just to work with the few, we want to work with the many. These 2 new partnerships will widen the bandwidth that we have with, if you like, your sector, and we will definitely be encouraging our members to engage in the dialogue as per the terms of the MOUs. So I think that will show once again that we're serious about this, and being part of this NBN process is very important too. And if there's any way we can contribute, and I was very taken with a number of the tools discussed today, particularly the OPAL one, which I know aggregate industries have already challenged their quarry managers to apply, and I think that's been quite educational for them. So we're on board with that. In terms of celebrating success, we have a key relationship with Natural England. They sponsor our Biodiversity Awards. We ran those in 2011. There's a biannual, or every 2-year process, so we're revving up for next year's event. I see it's 1 o'clock. I have got a very short film that I can show you, which I hope works. Is there anybody in that box? Yes, there is. Okay, if you could show the film. Short film just summarises some of the submissions we had to our last awards show. Work is in hand, as I say, for the event next year. We've widened the scope of submission there to capture niche measures, particularly to appeal to our SMEs who do great work. There's lots of good work going on in many of our member companies around the country, and that covers the whole of the UK. But they don't always have time to convert the story into something which we can promote for them. So we're hoping to lower the barrier of entry to them on that particular event. And I'm quite sure that we'll have an even better asset to take forward. In terms of what we're doing with influence, well, being here today, I hope influences some of you to appreciate, if only through the power of film that there is a lot here that can appeal to many of you, whether it's from just a scientifically rigorous end to just, if you like, the citizen science end of the spectrum. I think we're available and we will be outside to make connections with you. We have managed to get ourselves onto the DEFRA terrestrial biodiversity group, and I think that's again been illuminating to us, but hopefully illuminating to others. I think, as I've said, too many people do not appreciate what we can do and what we are doing. And finally, on education, I'm pleased that we've managed to secure the services of an intern from Cranfield to help us look into what does ecosystem services really mean and how can we make use of that and the whole sort of language of habitat banking. I think we feel that there is some genuinely useful stuff in there, and I think it will help us articulate the work that we do. So in terms of the future, we will be reporting back to you all, if you're available, next November with another parliamentary event. I do hope that we can attract the attention of the Minister once more. We're working on, and it's very interesting to see some of the work you're doing with all the modern technology. I've always had a concept in my head of a kind of virtual MPA national park where we scoop up all of the assets which exist throughout the UK that our members have developed and are developing, and put it in a place where it has, if you like, an identity and it's accessible. And I'm quite sure that there are some natural synergies between what we're trying to do and some of these very interesting tools that you've already developed and are rolling out. So I end on one of my 2 slides. If the only thing you take away is uniquely placed, that will be a result for me. I'm conscious that we're into lunch. That's always a bad thing to do on any day of the week, but never on a Friday. Thank you very much for your attention, and thank you for giving us the opportunity to sponsor your event. I hope you have a good afternoon.
Firstly, are there any questions for Nigel that you're bursting to ask, or you can always catch him later?
No, good.
Right. We could have run a competition on who drew up the longest species list. Before you go for lunch, I have something I have to do. The Trust likes to acknowledge the contribution that is being made by everyone towards developing the NBN, in particular the number of records that appear on the gateway. So I have here, this is a certificate which will be going to the Nottinghamshire Biodiversity Action Group for the 75 millionth record, which, wouldn't you believe it, was for Himalayan balsam. Unfortunately, no one from Nottinghamshire Biodiversity Action Group can be with us today, but can I ask Graham Wally to come up and accept this on their behalf? Transport that through to them. Okay, thank you, Graham. We now break for lunch, and we'll probably try and start again at 2:15 as swiftly as we can.